Introduction. Hey Priya, what are you doing with these sticks?
I'm making different shapes using these sticks. See, I have made a parallelogram.
This is good. Can you now make a triangle?
I can make, but I'm left with only 2 sticks now.
No problem, you can still make a triangle.
But how?
Give me the sticks. See, now both the shapes have the same base.
This was so easy.
Come, I will tell you more about such figures.
Objectives. At the end of this lesson, you'll be able to draw the figures on the same base and between the same parallels, understand the parallelograms on the same base and between the same parallels, understand the triangles on the same base and between the same parallels, prove the theorems related to the areas of parallelograms and triangles, and solve definitions. Students, the magnitude or measure of the planar region is called its area. And do you know what a planar region is? The part of the plane enclosed by a simple closed figure is called a planar region corresponding to that figure. Two congruent figures have equal areas, but the converse is not true. The area of a figure can also be denoted by AR. For example, figures on the same base. Look at this figure. We have got 2 figures here, a rectangle ABCD and a parallelogram CDEF. We can see that both the figures are on the same base CD. Similarly, in this figure, triangle ABC and triangle BCD are on the same base BC. Now look at this figure. Here a triangle ECD and a parallelogram ABCD are on the same base CD. Figures on the same base and between the same parallels. Now look at this figure. We can see that parallelogram ABEC and the parallelogram ABFD are on the same base AB. Also, the vertices CE of the parallelogram ABEC opposite to AB and vertices D and F of the parallelogram ABFD opposite to AB line on the same line CF, which is opposite to AB. So we can say that both the parallelograms lie on the same base AB and between the same parallels AB and CF. Similarly, in this figure, the triangles ADB and ACB both lie on the same base AB and between the same parallels AB and DC. So we can say that the two parallelograms on the same base and between the same parallels. Theorem. Parallelograms on the same base and between the same parallels are equal in area. Let us prove this theorem. Proof. Two parallelograms ABEC and ABFD on the same base AB and between the same parallels AB and CF are given. We need to prove that area of ABEC, area of ABFD. In triangle ADC and triangle BEF, angle ACD is equal to angle BEF because these are corresponding angles from AC parallel to BE and transversal CF. Mark it as 1. Angle ADC is equal to angle BFE because these are corresponding angles from AD parallel to BF and transversal CF. Mark it as 2. Therefore, angle CAD is equal to angle EBF, angle sum property of a triangle. Mark it as 3. Also, AC is equal to BE, opposite sides of the parallelogram ABEC. Mark it as 4. So, triangle ADC is congruent to triangle BEF by ASA rule using 1, 3 and 4. Therefore, area of ADC is equal to area of BEF because congruent figures have equal areas. Mark it as 5. Now, area of ABEC is equal to area ADC plus area ABED. Now we know that area of ADC is equal to area of BEF. Therefore, we can write it as area ABEC is equal to area BEF plus area ABED from 5, which is equal to area ABFD. So, parallelograms ABEC and ABFD are equal in converse of theorem. So we have proved that the parallelograms on the same base and between the same parallels are equal in area. The converse of this theorem is also true, which says that parallelograms on the same base or equal bases and having equal area. Example. Let's prove an example now. If a parallelogram and a triangle are on same base and in the same parallels, the parallelogram is double the triangle. Let the parallelogram ABCD and the triangle EBC be on the same base BC and in the same parallels AEBC, then the parallelogram ABCD is double the triangle EBC. Construction. Draw AC. Since AC bisects the parallelogram, therefore the parallelogram ABCD is double triangle ABC. But triangle ABC is equal to triangle EBC because they are on the same base BC and in the same parallels AEBC. Therefore, parallelogram ABCD is also double triangle EBC. Hence, diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at O. Prove that area of triangle AOD is equal to area of triangle BOC. Solution. It can be observed that triangle DAC and triangle DBC lie on the same base DC and between the same parallels AB and CD. Therefore, area of triangle DAC is equal to area of triangle DBC, which implies area of triangle DAC minus area of triangle DOC is equal to area of triangle DBC minus area of triangle DOC, which implies area of triangle AOD is equal to area of triangle BOC.